Kirkle Math. Let us continue our adventure of dividing fractions by dividing mixed numbers today. So we are going to continue to use that inverse operation to divide fractions, but we're going to focus on fractions that have mixed numbers. So here are our steps. We are going to rewrite the mixed numbers as fractions greater than 1, basically turn them to improper fractions. Okay, then you're just going to multiply using that brain tool of KCF, and then simplify as needed. That's it, guys. We are also pulling a lot of our questions from word problems as well as regular problems, because when you get mixed numbers, you usually are talking about some real life things like measurements, cooking, building something, and things like that. So our example today is Harold. 1 serving of Harold's favorite cereal contains 1 2/5 of an ounce. How many servings are in the 17.5 ounce box? So when you're setting up these division problems, you always need to ask yourself, you're going to have some number that you are dividing into so many groups, right? The second number is how many groups, or how many, the size of the group, right? So if I have 3 in each group, how many groups can I have? Then I'm dividing by 3. So it's either the number of groups or the size of each group. So when you're looking at problems, at word problems, you want to think, this is going to represent like the total, like all you got, right? Oh my gosh, I can't write today. Sorry. This is the total. This is all of the amount that you have. And the second number, the divisor, is like either how many groups or the size of each group that you're dividing this total into. And then in the end, you're either going to get the number of groups or the size of each group, depending on how you're dividing. So in our example here with Harold, he has 17.5 ounces of cereal. That's the total amount of cereal in his box. And each serving is 1 2/5 ounces. So we want to divide the 17.5 ounces into 1 2/5 groups, right? Into the size of each group is going to be 1 2/5 ounces, so that we can figure out how many servings he can have. Okay. So we're going to do what we said. So the first thing we have to do is rewrite that mixed number into improper numbers. And so as a reminder, we are multiplying the denominator times the whole number and adding the numerator. So we are going to do 17 times 2, or 2 times 17, plus 1. And that 36. So I think that's 36 halves. Okay, then over here, we're going to do the same thing. We're going to do 5 times 1 plus 2. That's 7 halves. So in the end, I'm going to get 36 over 2 divided by 7 over 2. Now, the next thing we're going to do is keep, flip, change. So I'm going to keep the first one, change the sign to times, and flip my second number upside down to 7. Okay, now we're going to multiply across. So I'm going to get 82 and 14. And so what I need to do now is simplify. So I could find the GCF of 82 and 14, or I can start guessing here. Let's see. Let's start with 2 and see. We know that that's going to be 36, and that's going to be 7. Can 7 go into 36? No. So now we're going to turn it into a mixed number. 36, how many times can 7 go into 36? That would be 5 times with 35, with 1 remaining. So 5 and 1/7 of a serving. Harold can have 5 full servings, and then 1/7 of an ounce would be remaining. All right, We're going to practice that some more. But remember, we wrote them as improper fractions, and then we keep, change, flip, and simplify. Okay, now we have Sheila. Sheila has 10.5 pounds of potato salad. So this is my total. Okay, she has 10.5 total pounds. She wants to divide the potato salad into containers which each hold 1 1/4 pounds. It's a lot of potato salad. How many containers does she need? Okay, so we took our total and we divided it into 1 1/4 chunks. We need to figure out how many chunks or groups are left. So first step, turn these improper. So I'm going to multiply and add. I'm going to multiply and add. So I'm going to do 2 times 10 is 20, plus 1 is 21. 4 times 1 is 4, plus 1 is 5. Now I am going to keep, change, flip. Keep the first one, change the sign to times, flip the second one upside down. Okay, here we are going to multiply straight across. 21 times 4 is going to be 84. 5 times 2 is 10. And now I'm going to simplify. So I could do how many times does 10 go into 84 first, or I could divide by the GCF of 84 and 10. Let's do this one first because I know that's going to be 8 times, and that's 80 with 4 left over. So this is going to be 8 and 4/10. Divide 4/10 by 2, and I'll get 8 as my whole number still, and 2/5. So she can get 8 and 2/5 containers. So again, if this is the real world, we're not going to have 2/5 of a container. So she's really going to have 8 containers that are full with 2/5 left over. 2/5 of a pound. Awesome. Okay. They like to use area of a rectangle a lot in math because it is something we deal with in real life. We've got rooms that are rectangles. We have gardens that are rectangles. We have rugs that are rectangles, tabletops that are rectangles. So we use it a lot, okay? So the first thing we need to remind ourselves is, how do I find the area of a rectangle? Okay, well, the area is length times width. So we're going to take the length here, I do cursive L's, times the width, okay? So the area of a rectangular sandbox is 56 2/3 square feet. Oh, hold on, I put that in the wrong spot. This is just things. The area of a rectangle is length times width, and that equals area. In my problem, the area of the sandbox is right here, 56 2/3. The length of the sandbox is 8.5 feet, and we do not know what the width is. This is the question mark. This is what we don't know. So I'm going to put these into this equation over here. I'm going to place them in there. I know that A, or area, is 56 2/3. I know length, or L, is 8.5. And I don't know what the width is. So you can put a box to represent that missing piece. You could put a question mark. You could put a W for width. Any of those would be appropriate. Okay. And what we need to do is figure out what the width is. Well, as we learned before, the inverse operation of multiplication is division. That means the opposite is division. So again, as a reminder, if 6 times 2 is 12, then 12 divided by 2 is 6. They are reverse images of each other. So I can actually divide my area by either the length or the width to figure out what the opposite missing piece is. So that's what we're going to do. We're going to do 56 2/3 divided by 8.5. And that will get me that missing piece because they are inverse operations of each other. Whew. All right, now we can actually start to divide. So what we're going to do is make them improper. So we're going to multiply and add, multiply and add. So let's see here. We'll do it over here to the side. 56 times 3. Let's see, that's 18. That's 15, 16. So that's going to, plus 2. So it's going to be 170 thirds divided by 8 times 2 is 16, 17 halves. Okay, keep, change, flip. And now we're going to multiply it out. Now, this is where I'm going to add something in here. This is something extra that not everyone learns, but one thing that you can do is called cross-canceling. So when you're doing your multiplication, if I know that there is a number that goes in evenly in a diagonal fashion, I can cross-cancel these. Basically, I can reduce before I multiply. Okay, so I'm going to show you both ways. So let's do it the normal way first. Let's do 170 times 2, which is going to be 34, so 340, over the 17 times 3, which is going to be, let's see, 7 times 3 is 21, 3 plus 2 is 5, so 51. But now you'll notice that I'll have to reduce this, and that's a really big number to reduce. So another thing that I could do, I'm going to do this one in purple, is I can say, well, I know that 17 goes into 17 one time. So 17 divided by 17 is 1. And 17 goes into 170 10 times. So now I'm going to be multiplying 10 thirds times 2 over 1. So my new number, we'll do it up here, is going to be 20 thirds. And you can already tell that is so much easier than doing what we just did, because I would have to know that 17 goes into this evenly. And if I divide, whoopsies, let me try that again. And if I divide 340 by 17, and I divide 51 by 17, I'm going to get the same answer of 20 over 3. So cross-canceling is just an easier way to simplify before you multiply. And they're really handy in word problems because of those really large numbers that usually exist in word problems. Okay, and we'll practice that some more as well. Okay, so I've got 20 over 3, and now I can turn that into a mixed number. 3 goes into 20 6 times with 2 thirds left over. So 6 2/3 feet is going to be my width. Okay. So we've done a couple word problems. Let's just practice on our own these. Okay, so take a minute and practice just multiplying straight or sorry, dividing. Keep, flip, change, turn them into improper fractions first. Okay, then come back and see if you got them right. All right, so you can see here, over here I put my whole number over 1, and I turned it into an improper fraction. Then I keep, change, flip, and I got 32/9, which is the same as 3 4/9. Down here, same thing, turn them improper, keep, change, flip. Okay, and then I showed you 2 ways. So if I multiply straight across, I get 50/15, and then I can reduce by 5 and get 10 thirds. Or if I do that cross-canceling, I know that 5 and 25 have 5 in common, so their GCF is 5. If I divide 5 by 5, I get 1. If I divide 25 by 5, I get 5. That way, when I multiply across, I get 10 and 3 right away. It is totally a preference thing, but both ways work. Okay. We're running out of some time here, but these are 2 problems that you can practice on your own, some word problems. And then if you have any questions, come see me in class or send me a message. but we're just, remember our steps are to turn them in proper first and then keep, change, flip, and simplify.